Alright, welcome to the fourth video in this vlog, where we're going to be using what we learned in the last video, which was about 2D vectors. Go check that out. We're going to be implementing what we learned in the last video into our physics engine, which we made in Unity. So, just a quick recap of that, right here. We saw that vectors are a way to store many numbers into one little entity, and in this case we only have two numbers in it, so it's our x and our y. So a vector can be split into its x and y components in this case, and so everything that is a vector within this magic equation of ours got split into um, the position x here is the position as a function of time equals to acceleration in the x direction in the into time squared, blah 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 blah. Then over here it's acceleration in the y direction, time squared, and all that jazz, right? And we also saw how a vector is its x component and y component into the unit vectors, right? Because through vector addition, you know that this is true. So you know that because of this, the x and y are just, or the x and y can be rewritten as these respectively. Okay, so let's head on over to our game engine, Unity, right here. And I'm going to be opening my physics engine script, which I've labeled WMP. Gonna double click on it, and I'll show you guys what that looks like. And so here I have the physics engine itself. It's decoupled from the actual player object, which is CubeBoy. And what CubeBoy does is it calls on this uh, physics engine because it's a public class, as you can see here. So what I do is I call on this physics engine, and then I set variables within here. But we don't really care about this part for now. What we care about is the actual physics, which is happening here. As you can see, and don't mind noises in the background, as you can see, we only have the code written for one axis right now, specifically the y-axis. What's happening is that we have three public vectors, and each of these vectors are vector 3's, as in they can hold an x, y, and a z, right? And so what we're doing is, for all of these, we're setting them as public vectors, but we're only accessing the .y, the y component of each of these. So technically, like, really, if we really wanted to add the x motion, x-axis into the motion of our game object, all we need to do, really, is Control-C this, Control-V, rename it from y value into x value, because those are the two axes that we're working with, and change all of the .y's into .x's. It's really that simple. Oh yeah, and then you also have to change the x value of the position vector, which is the end result of this entire function, and you just change it to our newly made x value in variable. And there you have it. It's really that simple. So if we head on over to the game engine itself, Unity, it's gonna load stuff. Oh, it already loaded everything. Okay, and click on CubeBoy. This is showing, right? Okay. Click on CubeBoy, and now what we can do is we can change the numbers of our x values for acceleration, initial speed, and initial position, and they'll actually do things. Before they didn't really do much, but now they'll actually work. But here's the thing. Just realize this. We haven't yet changed anything within the CubeBoy game script, right? Because we changed the physics itself, yeah, but CubeBoy isn't calling on it. So, let me just double check. Always double check if you have everything right. So, double check if we have CubeBoy all set up for these new and improved physics that we're adding in here. So our initial position is equal to our transform.position. That's all fine. That's all fine. We're making physics. We're calling on this class WMP. We're calling it phys equals to new WMP. Yeah. Initial speed, which is a vector. Vector. We have all of these public vectors here as well. Okay, that's fine, fine. Initial position equals to initial position. Okay, that's all right. Acceleration equals to acceleration. Time transform dot position equals to phys dot. Everything seems to be working fine. Now we go and test it in Unity. This way we'll know for sure if everything actually works. So what we'll do first is we'll zero our accelerations, right? First, we only want our initial speed. First, we're going to check if y is still working, if our code didn't mess up what we had already done. And let me show you guys what I'm doing here. Right, so I'm changing the y value so that we know that whatever we just added doesn't mess it up. Oh, I clicked outside. Hit Control P. Alright, our cube is slowly floating upwards. That works. Okay, now for the real test, let's see if our x values are working. So let's set that to something like 3. Hit Control P. Oh, good, that's really nice. It's working. As you can see here, it's floating off to the side. I don't know if you can call that floating, but you get the idea. So, recenter on our cube game object. Zoom out a little. Ooh. Okay, now for the real test. Can we run both things at the same time? I'm pretty sure we can, because we just did each by themselves, right? So technically speaking, you can have both run at the same time. So we'll have this, 3, 2, 1. And bam, just like that, our cube is now moving diagonally in 2 dimensions. As you can see, it's our x and our y. And Unity actually even highlights those axes for you. See? The green is our y and the red is our x. Now we can seriously mess around with some stuff. For example, remember the ball situation that I showed you guys in the previous video? If you don't know what I'm talking about, go check that previous video out. It's a very nice video. So we just add in negative 9.81 as our acceleration downwards, because that imitates gravity. We add, let's say 5, no, we want a big number. 10 as our initial speed on the x, and 10 on the y. Remember to do both x and y, otherwise it won't work. What will happen if I don't add the y is the thing will just start to fall immediately. So you need to have the nice little arc to really get a nice view. But actually, now that I think about it, 5 for x and then 20 for y, because if I had set it to 10, within like about 1.5 seconds, it would already be going down. So it would be a really small throw. Your friend would never have even been able to get that ball to your hands. It would have dropped to his feet. Control P. And, as you can see, after a little bit of delay or lag, Unity does it, and it falls in a parabolic motion. Okay, that's great. And then, this is all fine. But you know how I had to change both X and Y each time, right? Well, in real life, whenever you get a situation like the friend throwing a ball, the initial velocity is actually never described as 2 different things. You have to do it yourself. You have to split that one velocity vector which is given to you into the 2 I and j components. And we learned how to do that in the previous video, about which uses the x component and the y component. The x component gets multiplied into cos theta, y component into sine theta. So how can we imitate that here? Well, if you pop back into the Visual Studio, specifically the physics engine, right now our initial speed is a vector 3, as I said earlier on in this video, meaning it has 3 components, x, y, z. But as I said, you're in a physics problem, you're only going to get one number, one magnitude of that vector, right? The magnitude is its length. So it doesn't have 3 components, honestly. It only has one component, meaning it's going to be an integer, but this still doesn't make any sense. Your initial speed has to have 3 components, or in this case 2 components, because it's got an x and a y, correct? That must mean that this isn't actually a vector. It doesn't have the x and y to begin with. It's the magnitude of our initial speed. So we say initial speed underscore mag to show that it's the magnitude. But then, in order to take care of the cosine sine thing, we create another public integer. Sure. We call it initial underscore speed, and let's call it the direction, dir, and hit save. Now what you essentially have is a variable for the size of your vector, the length, and the variable for which way it is pointing. The two things you need in order to break it down into its I and j components. So how do we do that in code? Well, basically we do what we did on the blackboard. You take your initial speed.y thing, right, your velocity, and you delete it. What we're first going to do is we're going to add brackets to make it a little neater, right? Understand order of operations. And we know that it's going to be the magnitude into cos theta, which is our angle. So in this case, the magnitude of our vector, or of our initial speed vector, is here in this variable. We multiply it into math dot cos. This allows, oh wait, math f dot cos. This allows for Unity to call upon its mathematics functions. So in this case, cosine. Math f dot cos, and then initial speed direction, which is going to be some number that we put in, and it's going to be in degrees. But the thing is, this is a thing with Unity's mathf dot any sort of trigonometric. Oh, I cannot pronounce that word. Trigonometric functions. It only takes things in radians. And this number we're going to do in degrees, because honestly, I don't want to calculate what 45 degrees is in radians. Actually, that's kind of easy. 39 degrees is in radians, right? So what we do is we do the conversion for degrees to radians in here. What we do is we do the number in degrees, which is our initial speed direction, into, oh wait, this is my, oh, never mind. I'm going to change this to sine. Always double check your code, because this is my y value. If I put in cos, then I would have had some sort of weird, wacky inverse, not flipped motion, where every time I put in my y value, it actually goes towards the x value. It would have been really weird. So, here, initial speed direction, which is going our degrees, right? And to turn it into radians, what we do is we multiply it into pi, and you can't really call on pi without using mathf. So you do mathf dot pi divided by 180 degrees. And this is going to be explained in the next video, actually, about why I have pi over 180 being multiplied into degrees, but that's going to be in a later video. Let's not worry about it right now. Just know that this is the conversion for degrees to radians. You take your amount in degrees, multiply it into pi over 180. And that should solve it. Now what we do is we do the same thing here, but wait a moment. Remember, I put brackets here, or parentheses, whatever you want to call them. I put parentheses here, so I'm going to double check real quick if my parentheses make sense. I start here, yeah, then I make another one. Then I have one that ends this one and one that's, yes, it checks out. Always double check. Right, now what I'm gonna do is I'm gonna do the exact same thing. Initial speed magnitude into mathf dot cos this time, because we're dealing with the x-axis, into initial, oh, I didn't spell that right. Remember to spell your variables right, otherwise it's not going to be the same variable. Sometimes you might even spell it so wrong that it becomes a different variable. Don't do that, not a good idea. Mathf dot pi, ooh, pi over 180. And that should solve everything. Now what we essentially have is the user is going to input some magnitude. It's going to they're going to input some direction, angle theta from the horizontal, in an anti-clockwise motion. And in the end, we're going to end up with a vector, which we're going to break down into its y and x components. Oh, this is why you always double check. MathF does not work with a lowercase m, it only works with an uppercase m. Unity does not recognize lowercase mathf, it only recognizes uppercase mathf. Okay, now we check our game object, right? To see if everything works out. And right away you notice that our initial speed is the vector 3 here, because we didn't change it. We don't want that anymore because it changed. Times keep changing. Gotta keep up with it. Keep up with the times. Anyways, that's my attempt at humor. Public int initial underscore speed. Ooh, this is why spelling mistakes are a huge problem in coding. Direction. Right, so now we have the public variables in place for our new variables that we made in the physics engine. So all we need to do now is change these so that we can actually make some sense out of this code. Goes to mag speed magnitude, right? That checks out. We do phys dot initial. Why isn't it lighting up? Huh. I think it's because I'm writing something right now. Speed underscore dir is equal to initial speed underscore dir. Gotta love the automatic finish, and everything should be working just fine now. So let's head on over to Unity one last time, hopefully. It's going to compile the scripts. Oh, what's the error? Initial speed. let's go back. The console is throwing up an error. And usually whenever the console throws up an error, it has a reason to do so. Solution. Got it. Let's go back here. And I'm just going to double check my main copy of this, because what I do is I write up all of the code beforehand and then do the video on it later. So here's my main copy. Don't look. Answer sheet. It's equal to direction, public int, vector 3. What do I have? X value, Y value, sine, cosine, position. Just bear with me here. This shouldn't take too long, which is why I'm bothering to keep this in. Ah, right. Such a simple mistake. You see, spelling matters a lot in coding. Right here, I made a spelling mistake. That was it. I didn't need my good copy. I was alright. All I did was make a spelling error. Check your spelling. All of those English lessons are going to come in handy when you code. And there, as you can see, our initial speed magnitude is now available as a public variable that we can go down and up. Down and up. Anyways, we can do that. It's a lot of fun doing this. And we also have some initial speed direction right here. So, let's test it out. In theory, if I put in some 20 as my magnitude and then have it at 45 degrees off the horizontal, it should shoot off in a perfect arc and go actually the farthest distance possible, which will also be explained in a later video. Because that is interesting, and it cannot be kept within one video. It has to be in two. Alright, and Control P. It's going to read everything. And there it goes, it works! That's amazing. Now we don't have to bother with changing our X and our Y as we had to do before. Also, you can do what I just did with any of these three things. Acceleration, magnitude, and position. You can do it with any of them. It's just that in this case, I decided to do speed, as that's what you usually get. I don't think you get acceleration at a different direction, but I haven't progressed too far into physics yet, so I don't know. But usually acceleration is stated as different components. You're accelerating this fast in a car sideways, and you also have gravity, and you're about to fall off a cliff situation, right? So you know how fast you're accelerating, and you know that gravity is existent. It's X and Y. They don't tell you you're going at some angle theta, some magnitude this way. So, anyways, now what we have is we can set the magnitude, we can just set our velocity, right? And then we can set the direction that we want to go in. And then this is going to be incredibly helpful once we get this into 3D, because you'll be able to point in literally any direction you want and it'll shoot it. Like you're shooting a sort of like ball to your friend. It works perfectly and it's doing exactly what it's supposed to do. So, that's it for this video. What we learned is how to make one variable that will act as our initial velocity, and then use the angle theta to turn it into its I and J components within Unity. And we did that, put it into our physics engine, and it's all good. Check out my other videos. Those will prove to be helpful if you have not watched them and you're watching this and you have no idea what I mean by magic equation. I explained that in my first video. You don't know what the physics engine is, that's the second video. So go check those out, and yeah, see ya.